Hello friends, in this session we will learn the preparations, physical properties and chemical properties of glucose molecules. Formula of glucose, as you know, this is C6H12O6. It is also called as hexose or dextrose sugar. Preparation we will study there are two preparations. Preparation one is the lab method and second your manufacture. So in lab method we are using the cane sugar, and cane sugar generally they are made up of sucrose mostly, and under acid hydrolysis means in presence of water, in presence of dilute HCl, it will react with the sucrose. This is the formula of sucrose. It will give you glucose plus fructose. These two different products are given by the cane sugar. Formula is same, you can see here. This is glucose is also called as the grape sugar apart from the dextrose, and fructose is called as the fruit sugar. But you can see the formula is different. One is your aldehydic sugar and second your ketonic sugar. This is soluble in alcohol, but glucose is less soluble in alcohol. This is the difference, and due to this less solubility in alcohol, this is again separate out after the crystallization. Then in this way we are getting the glucose, but sucrose is soluble in water. Manufacture, if you determine in case of manufacture, we take the cane or potato starch, which consists of starch in large quantities, and again we are doing acidic hydrolysis under 2-3 atmosphere or 100 degrees centigrade. It will again form glucose. Starch is your homopolysaccharides. Excess acid in case of a starch is again it is neutralized by the chalk, or after chalk this glucose is again filtrate. It is become insoluble solids. It is less soluble in alcoholic solutions, and then after the separation of this one as a filtrate, this glucose is decolored by the animal charcoal. This filtrates, then we will get the glucose. Glucose again it is solution is concentrated and separated under the reduced pressure, and we will get the glucose in crystalline form. So this is our formation of glucose. Physical properties. So they are readily soluble in water, and this solubility is endothermic dissolution. Means after dissolutions, the glucose will the temperature of the solution will becomes decreased. It is less soluble in alcohol but insoluble in ether. Okay, why it is soluble in water? One more thing is that they have large number of polyhydroxy groups. So due to this polyhydroxy groups, it being in organic compounds, this will help in hydrogen bonding, and it is soluble in water. Sweetness, 3/4 sweetness than cane sugar, means 75% almost. It is less sweet. It is solid at room temperature. That is the crystalline properties. Chemical properties. This is our exact structure of the glucose. CHO, OH is on right hand side, this OH is left hand side, carbon 1, carbon 2, carbon 3, third carbon OH is left hand side, remaining all 2, 4 and 5 is on right hand side. 6th your CH2OH, that is called as primary alcohol. So we have 5 OH group, 1, 2, 3, 4 and 5. This is one primary alcohol. 4, 1, 2, 3, 4. 4 is secondary alcohol, 1 aldehyde groups, and this 6 carbon chain. So how this whole structure was identified? Let us see what are the evidence for the open structure of glucose. For open structure, this formula was derived from the elemental analysis and molecular mass determinations. In this way, this formula was derived. To identify the 6 carbon chain, this glucose was react with the red phosphorus and hydrogen iodide by heating. So the scientists got the 6 carbon chain N-hexane. One more product is there. There is 2-iodo. Hexane is also there. So this also product was there, but there was 6 carbon chain. Presence of carbonyl group. How they identify the carbonyl group? So by reaction with the HCN, hydrogen cyanide. So this will give you your cyanohydrin. Cyanohydrin is the property of only carbonyl group. Again reacting with the hydroxylamine, so it will give you monooxime. So NOH is your monooxime. So when this is monooxime, that this will tell you this is N. The glucose contains one carbonyl group. Presence of again aldehyde groups. So when they are reacting with the bromine water. So bromine water is a mild oxidizing agent. So glucose will give you gluconic acid. So property of gluconic acid is it is a CHO can only mildly oxidized. There are other mild oxidizing agent like this one, tolerance reagent. So tolerance reagents, what will happen? So in this way, tolerance is solution reduce glucose oxidized to give you carboxylic acid like previous bromine water, and tolerance reagent will give you silver mirror or black PPT. Aldehyde undergoing failing solution, basic solution, it will convert it to again gluconic acid. So failing solution, silver tolerance reagent, bromine water, they will convert all this CHO under the CHO will be oxidized to give you carboxylic acid, and which is nothing but a gluconic acid plus red PPT of from the failing solution. So all this will identify that the compound contain CHO group. Presence of 5 hydroxyl group, how this was identified? The glucose was reacted with the acetyl chloride, or you can use the acetic anhydride. So this oxygen OH part is reacting with the acetyl chloride, Cl is removed, and here from here hydrogen OH is removed, so you will get here compound hydrogen removed from the glucose and Cl removed from here. So you will get CHO, CHO plus CO, Cl. So you will get here compound here 5HCl. Okay, and if you are using acetic anhydride, so acetic anhydride, so you will get product acetic acid and glucose pentacetate. So glucose pentacetate means it consists of 5 OH groups, and it is again it does not contain acetic compound. Why? Because it is neutral towards the water. So by seeing all these structures, the glucose molecules were ultimately got this type of structure, but this structure was incomplete structure. So why? Because already I discussed in third carbon OH was changed. So this is not a definite configurations. It has 4 asymmetric carbons. Okay, it's not properly assigned because this carbon is your third carbon we have seen in previous page. It is your OH is second carbon OH is this side and third carbon OH is right side. So it is not properly assigned. All are same side. So configuration of D-glucose was actually proved by this scientist called as Emil Fischer. So we will see later on. And glucose is reacting with the concentrated nitric acid. This is very strong oxidizing agent. So what will happen? The glucose will be converted to saccharic acid. So saccharic acid means like even the first carbon that is primary alcohol is there, that is also consists of OH groups. So this is also confirming. So it has almost it has only at least one primary group. Means it has no, it's not giving, it's neutral to water, means it does not have any carboxylic group or acids, acidic hydrogen. And with this nitric acid means at least it has one primary group, rest of the group will be secondary. So this reaction confirms it has one primary group, primary alcoholic group. Chemical reaction of glucose. So we will see there are two type of reactions. One is due to hydroxy group and one due to aldehyde groups, or you can say carbonyl groups. So let us see reactions of hydroxyl groups. With hydroxyl groups, the reaction glucose is reacting with the acetyl chloride in pyridine or anhydrous zinc chloride. So in this case, what will happen? So we will getting the H from Cl, already the hydrogen plus Cl will be removed as a hydrochloric acid, and this whole OH will convert into glucose pentacetate. So mixture of there are two type of group is there. One is alpha and beta. This we will discuss later on. What is meaning of alpha and what is meaning of beta? But this will tell the structure is actually cyclic structures. That's why this structure is given. So why it is called cyclic structure we will discuss later on. But we are getting the pentacetate. This is the only proof. With PCl5, phosphorus pentachloride on heating, all OH is replaced by the Cl. So substitution will take place. And then with PCl5 we know the side products are POCl3 and Cl is produced. So we will get pentachloroglucose. With metallic hydroxide like calcium hydroxide, barium hydroxide and copper hydroxide, the glucose which OH is there, so OH will be reactive with the calcium hydroxide and dehydration will take place, and we will get calcium, and calcium glucosate is produced, and this is soluble in water. With methanol, so if you are reacting with the methanol, what will happen? So with methanol in presence of dry HCl, so it will give you again two type of compound. One is alpha and beta methyl glucosides. So this reaction also confirms that this is a cyclic structure. We will study later on what is meaning of cyclic structures after this session. But the reaction will take place like this only. So this is our cyclic structures, and we can see this is your alpha D methyl glucoside, and this is your beta D methyl glucoside. What is meaning of alpha D? Alpha D means we have OCH3 right hand side and beta D methyl glucoside. These are the glucosides in which the OCH3 in left hand side. Both melting point is different. This means these two are different compounds. This will supporting the cyclic structures. Cyclic structures is done by one CH3COCl acetaldehyde, and one is your methanol. So we will see this reaction when glucose is proving the cyclic structures. Reactions due to carbonyl group. So this is our glucose. One reaction is reduction oxidations. Okay, with these two reactions, we will see what are the different chemical reactions. So when you are reacting this D-glucose in sodium amalgam and water, you can use catalytic hydrogenations. So what will happen here? You can see here, so this is converted into this is your CHO. So CHO will this will undergo reduction and it will go convert to methanol. You can see clearly. So this compound is called as D-glucitol. That is also called as sorbitol. Sorbitol means the aldehyde group is again hydrogenated, or it is reduced by this one sodium amalgam. Reduction will take place and convert to your alcohol. The same compound sorbitol, this is sorbitol, is also converted by D-fructose. This is your D-glucose. So D-fructose, if you give sodium amalgam, so it will also convert to glucitol or sorbitol. But at the same time, if you are this is a ketone, it will give you one more product that is called D-mannitol. So you can see in the both the differences there. So one here is this ketonic group. So this is again also converted. So this converted into this type or this type. So there is a configuration at second carbon. So due to second carbon, we are getting two products in case of fructose. One is sorbitol and mannitol, while glucose only one product. And again, glucose is given hydrogen iodide phosphorus. You know, we get two type of product. One is hexane and second is 2-iodohexane. Next is oxidation. Oxidation already we discussed with tolerance reagent. This tolerance reagent is the solution of silver nitrate and ammonical solutions. So we will get these two reactant will react to give silver hydroxide, and silver hydroxide will give silver oxide. Silver oxide is reacting with this aldehydic part of the group and will convert into carboxylic acid, and silver mirror is there. This is the black PPT. So this is the mild oxidizing agent. Second mild oxidizing agent is Fehling solution. So we'll take alkaline copper sulfate solution. So you will it is reacting with sodium hydroxide to give Cu copper hydroxide, and copper hydroxide on heating give copper oxides. And this copper that is the oxides, copper 2 oxide will react with the glucose. So aldehydic part will convert into COH. This again gluconic acid or aldonic acid, and we will get the red PPT of CO2O. Again, you use the bromine water. So in case of bromine water, what will happen? The CHO will convert into carboxylic acid. It's called gluconic acid. Means tolerance reagent, Fehling solutions, and bromine water will are the only test for identification of glucose. But bromine water test for two glucose and fructose. Fructose does not give the bromine water test because they have ketonic sugar. Only glucose will give. This is the difference between glucose and fructose. With nitric acid, or you can use any other strong oxidizing agent. So it will also convert even primary alcohol like CHO is converted into oxalic acid, carboxylic acid, and even the primary alcohol will also convert into carboxylic acid, not secondary alcohol. This is the property of nitric acid. So we will get a 2-dicarboxylic acid, that is called saccharic acid or glucaric acid. Next reaction is with periodic acid. So this is CHO group and is reacting with the HIO. This is HIO4, not 3. So 5 molecules of periodic acid is there. So there is a 5 oxidative cleavage take place. So it is take place between aldehyde and oxygen. So this oxygen should be continuous. You can see we have all oxygens continuous. So cleavage will take place carbon between 2 carbon with aldehyde and oxygen present, or between 2 oxygen. So this will convert CHO is there, this will convert to formaldehyde, but this will convert into your formic acid, you know, both the side OH will take place. So OH will be added, you will get this one, and this will convert into HiO3. So like that, this cleavage take place, it will convert into, if it is cleaving over here, this will convert to carbonyl compound HiO3 and water. And if you are taking this compound, there is no continuous OH there, so there is no reaction will take place. This is one of the important reactions. It is used in asking the competitions, examinations. This is our ketonic sugar. CO is there, so the cleavage will take place between ketones or between two OH. So there will be two cleavage will take place. You will get here CH3 CO, and this will be OH. So it will convert to carboxylic acid, that is acetic acid. This will convert into formic acid, and this will convert into aldehyde. So we have some more reactions. So one reaction is with HCN. HCN will form the addition product. So it will react with the only CHO group. So it will form a cyanohydrine. Again, cyanohydrine, that is glucose cyanohydrine, and glucose cyanohydrine is undergo hydrolysis. So this will only hydrolyze. After hydrolysis, you will get the heptanoic acid. So again, heptanoic acid, it is a reaction with the, on further reaction, it can give your that is chain that is called monosaccharide carbon chain. Further reaction of this one, so you will get your normal saccharide chain, 6 carbon chain. And with ammonium hydroxide, so this will give you your glucose oxime. So only the carbyl part of the oxygen will react with the oxide, this is hydroxylamine, to give glucose oxime like this one. And one of the very important reaction, that is phenylhydrazine, that is called Fischer's mechanisms. So in this case, CHO, CHOH, so this remaining part is same, so that I am not writing, only this part and this part is important. So carbonyl part will react with the your phenylhydrazine, this is called H2NN C6H5, this is phenylhydrazine. So this is the first molecule, you will get this compound glucose phenylhydrazone. Then again, by giving again second molecule of your phenylhydrazine, so this will reacting with the second molecule, so this will oxidize the second molecule, so you will get, it will convert into fructose. So this whole process is called as Amadori rearrangement. So you can see I have written this side Amadori rearrangement. This is a glucose and this is CHOH, and how it is undergoing reacting with the phenylhydrazine. This is a phenylhydrazine, so NH&NH6H5, so hydrogen from here reacting with this is making 6-member ring. And after this one, this will form compound, this one is aniline. So there is 2 hydrogen in this phenylhydrazine. So 1 hydrogen will from the alcohol, from here the 2 hydrogen will be oxidized, will give to, one will give to CCH5 aniline, and second is ammonia. So from 2 hydrogen convert into aniline and ammonia. Again this will react with the third hydrogen, the third phenylhydrazine. So this will ketone will react with the third phenylhydrazine, and you will get this product, and this product is called as glucosazone. This is your yellow solid, and its melting point is very, very sharp. So in examination they are asking, the examination question comes, in glucose how many phenylhydrazine requires? So we require 1, 2 and 3. So second phenylhydrazine will react, undergo Amadori rearrangement to convert into fructose molecules. This whole mechanism of this is phenylhydrazine with glucose. Glucose with concentrated HCl. So in presence of concentrated HCl, it will form acid that is called levulinic acids, CH3CO, CH2, CH2COH, and formic acid and water. Again, it can also give this compound that is called 5-member ring compound. You can see CHO 1, 2, 3, 4 5 carbon is there. It is a cyclic compound that is in ring form only. This ring is called as 5-hydroxymethylfurfuryl. And if this ring is reacting with the alpha-naphthol, alcoholic alpha-naphthol, alpha-naphthol is this compound. You can see this is a cyclic ring. This is alpha oxygen or hydroxy group is there, this alpha-naphthol. And after adding this alcoholic alpha-naphthol and just drop 1 ml of concentrated sulfuric acid, you will get the junction between H2SO4 and alcohol, the alpha-naphthol. You will get the violet ring like coloration. So this is the identification of your glucose, that is called as Mollis test for carbohydrates. One of the important reactions usually asked in the competitions. Next our fermentation and then dehydration. So fermentation means in presence of zymes it will ferment to give ethanol plus carbon dioxide, and with the concentrated sulfuric acid, strong acids, if you heating strongly it will dehydrate to form black carbon. So this is a dehydration process to become a sugar carbon. And the reaction with alkalis acid we have seen, so we react with the concentrated alkalis, it becomes turned yellow, then brown, and then it becomes resinous mass. But if you are giving the dilute alkali, so in presence of dilute alkali it will give you fructose plus mannose. These two are epimers. So epimers, you know, it is arrangement of the second carbon, configuration of second carbon. So how it is you are under reacting with alkalis. So this is the CHO, C2 OH group, this is glucose, remaining is part is same. So this will again tautomerize to form enol. So hydrogen will from here it will transfer to this carbon. So OH is there. So when it will transfer to this hydrogen. So this hydrogen is transferring to this oxygen. So this is your 1,3 arrangement. So when this will go this oxygen, you will get here enol compound, and from here you can see here it is getting fructose. This is a reversible reaction, and in this reaction again this hydrogen is transferred to this carbon. So we will get fructose, and from here reaction will again this double bond will shift here. So hydrogen can move to two sides. One is OH this side and right hand side, one is left hand side. If this hydrogen move to left hand side, so if we move to left hand side, so you will get here enol, and if it moves to hydrogen moves to right hand side, you will get the mannose. So this is the configuration will take place. So this whole reaction is called as low-bri Bruin 1 Eckernstein rearrangement reactions, because due to 1,2 enolization these different type of structures are formed. Fructose, glucose and mannose structures are there. So in this way we can say glucose and mannose are C2 epimers. So this is the pictorial diagram of reaction of glucose. The glucose, you can see the reaction with acetyl chloride, glucose acetate with PCl5 pentachloroglucose with hydrazine. Already we have discussed we require 3 molecules of phenylhydrazine with sodium malcolm sorbitan for glucose. For fructose we get mannitol also. Then with tolerance reagent, failing solutions and concentrated nitric acid, these are the mild oxidizing agent. Even bromine water is there. So bromine water is only applicable for glucose, not for fructose. Hydroxylamine, it will form glucosamine. With HCl it will form glucose cyanohydrine, and NaBH4 with water it will form your again sorbitol, and with H phosphorus and this one HI it will form hexane. With nitric acid forms saccharic acid. So just to go through all this reaction, it will be very helpful in revising whole chapter. Thank you very much.